All right, this is a key to the worksheet on properties of polynomials, and in each of those problems you're asked to find the degree of, in this case will be each term, and in this case will be the polynomial. All right, so let's talk about number one. And you can't see the exponents very well, so I'm going to just go ahead and write these here. So number one, you have, and this is 1a, in 1a you have 6x to the 8th. Okay, so when determining the degree of a polynomial, and a monomial is considered a polynomial. Here, notice though there's only one variable. So the degree of a polynomial, in this case the monomial, has nothing to do with the coefficient. So don't even look at the coefficient to determine the degree. It has nothing to do with the coefficient. The degree of a polynomial has to do with the exponent of the variables. So since I only have one variable here, the degree is that exponent. So the degree here is 8. Okay? So whenever you have a monomial, it's pretty easy to determine the degree. You just look at the exponent. In this case, it's just one variable, so that's easy to find. But in B, if you look at B, this is what you have. You have negative 3x to the fourth, y to the third power. Remember, the degree has nothing to do with the coefficient. It only has to do with the exponents. Notice here, though, there are two variables. So you have to find the degree, you have to look at the exponents of each one and then add them up. Okay, now this is a monomial, all right? So that's how you find the degree of a monomial. The degree of a monomial, there's more than one variable, you add the exponents. So the degree here is going to be 4 plus 3, which is 7. Okay, so that's the degree of this monomial. Let's look at letter C. Letter C, we have 4x. Well, similar to 1a, right? There's only one variable. What's that exponent? That exponent is 1. So the degree here is 1. In D, we have 4a cubed b squared c. Notice I have three variables, so I've got to look at the exponents. This is 3, this is 2, this is 1. That implied 1. So the degree, you're going to say 3 plus 2 plus 1, which will be 6. And then E, you have the constant 8. Now, some students get confused about that because they don't see a variable, right? So if there's no variable in that monomial, then how do we find the degree? Well, you got to remember something. So remember that 8 I can write as 8x to the 0 power, because remember x to the 0 power is the number 1, is defined to be 1, as long as the variable does not represent the number 0. So that's understood to be 1. So 8 times 1 is 8. So the exponent here is 0. So the degree of a constant is 0. So remember, the degree of a constant, see, that's a constant, there's no variable. The degree of a constant is always 0. Okay? All right, so that's number 1. Now, so remember, all these were monomials. Now, remember, a monomial is considered a polynomial. So let's look at number 2, though. Number 2, we actually look at polynomials where there's more than one term. So all these are more than one term. So let's look at 2a. So in 2a, we have 7x minus 2. You have to notice there are two terms here. Okay? There are two terms. So to find the degree of this polynomial with more than one term, you have to find the degree of each term. Okay? So I'm going to put it down here, the degree. All right, so let's talk about this. The degree of that first term, 7x, is 7x to the first, that's 1. The degree of that constant is 0. All right, so the degree of that first term is 1. The degree of that second term, which is a constant, we talked about that, constant, is 0. The degree of that polynomial is going to be the degree, the largest degree that you see. So let's talk about it that way. The largest degree that you see. So degree 1, 0, the largest is 1. So degree equals 1. Okay? So the largest degree you see. Always pick the largest degree. Or the largest number, I should say. Let's put the number, because the degree of the polynomial, there's only one, and that's That's going to be the largest number that you see here. So the largest degree of a term. Okay, put it that way. Large degree of a term. Okay, B, we have 3x to the fifth minus 7x cubed plus 5x minus 2. First of all, you have to know how many terms there are. There's 1, 2, 3, 4. There are 4 terms. Remember, terms are separated by addition, subtraction. All right, now keep in mind though, and some students get confused, they think of this term as 7x cubed, but it's not 7x cubed, it's a negative 7x cubed. So always keep the sign, and this constant's a negative 2, so always keep the sign with that term. So we want to find the degree, right? So the degree of this polynomial. We got to find the degree of each of those terms. So the degree of this term, there's only one variable, so that's an easy one. So that's 5. So put this as degree. And when I say degree, I'm talking about the degree of each of those terms, okay? The degree of this term, negative 7x cubed, is 3. The degree of this term, positive 5x, is x, remember x to the first, so that would be 1. The degree of a constant is always 0. So what's the largest you see? The largest you see is 5, so the degree is 5. All right, C, you have 4x squared minus 8x to the fourth plus 3x minus 1. Again, you need to know your terms, so I have 4 terms. 1, 2, 3, 4. We got to find the degree of each of those terms, and the degree of the polynomial will be the largest one listed. The degree of this first term is, the first term, 4x squared, is 2. The degree of that second term, negative 8x to the fourth, is 4. The degree of that third term, 3x to the first, is 1. The degree of a constant is 0. What's the largest number you see? The largest number you see is 4. So the degree of the polynomial is 4. Okay? All right, let's look at letter D. So it's not difficult, right? Very simple process. It's a very simple idea to determine degrees. And those degrees are going to be important later on in the course. So you're going to see the connection between this and something else when we get to it. So 3x squared y plus 4x cubed y to the fifth plus 3x to the fourth minus 7y. All right, notice this time you have different variables involved. So the previous 3, and when I say previous 3, I mean these, were fairly easy to do because they all had one variable. There's only one variable in the polynomial, that was x. Here you have x and y's, right? So you notice though your terms, there's 1 term, 2, 3, and 4. So 4 terms. So we want to find the degree of this polynomial. To find the degree of the polynomial, we have to find the degree of each term. Now remember, you have 2 variables here, so this term, 3x squared y, there are 2 variables. The degree would be the sum of the exponents. So you add those exponents. 2 plus 1 is 3. Here, 4x cubed y to the fifth, you have 2 variables, you add their exponents. 3 plus 5 is 8. Here there's only 1 variable, so it's just going to be that exponent. Here there's a negative 7y to the first, so the degree is 1. And so the degree of this polynomial is the largest degree you see, the largest degree of a term, so that would be 8. So the degree of this one is 8. All right, and then finally let's look at E. So E, we have x squared y to the fourth plus x to the eighth minus x cubed y. So in this polynomial there are 3 terms, x squared y to the fourth, a positive x to the eighth, and a negative x cubed y. So in this term here, I have 2 variables. You add their exponents. 2 plus 4 is 6 to find the degree. So the degree. So to find the degree of a term with more than 1 variable, you add the exponents. Here there's only 1 variable, the degree is 8. Here there are 2 variables. This is 3, this is 1, 3 plus 1 is 4. And so therefore the degree of this polynomial, will be the degree of the term that's the highest. So that'd be 8 here. So 8 again. Okay? All right, so that is the key to the worksheet on properties of polynomial, and this worksheet dealt with finding degrees.